Hello. Hello everyone. Um, so my name is Alp Köse. I'm working as a DevOps engineer in CodiLime. Maybe Adam.
Hey guys, yeah, my name's Adam Baumeister and I work for Palo Alto Networks. Have we got any Palo Alto Networks customers in the audience? No one's even going to admit to it. Jeez. And I'm a global solutions architect working for Palo Alto.
Okay, so we prepared you a presentation with Palo Alto Networks that on a customer project that we worked on for the upgrade automation. So let's start. We will present you a customer success story that we achieved recently, and we made it to an automation tool. Reusable, where we can also use this in different environments and different customers. So what we were tasked with was the customer had like more than 500 firewalls, and they were like very in a business that had strict maintenance windows, and like we needed to ensure their confidence on their upgrades. So the customer was operating in a healthcare industry, so they had like more than 700 care sites and more than 100 hospitals. So we needed to ensure that the security, the updates they have, ensure that they're using the latest security features. And they, like I said, they had like strict maintenance windows, and they were like scheduling this before a month maybe for these upgrades to take effect. So we could have done this manually as well. So like I said, there were quite large number of firewalls. But this would probably take months. Like we would need to schedule lots of maintenance windows to accomplish this number of firewalls to be upgraded. And during that time, the software would already be probably like new software will be available, and we need to minimize this downtime for the customer. So like this should be like a solid solution that works in a consistent way. So of course, manual delivery would mean like human error, not the steps could not be repeated in an exact manner each time, maybe. So this led the decision on an automated approach. So we could run this automation in a higher pace, executing it in like multiple firewalls at a time on different environments, adapting it to different requirements of the customers. So this could also be reusable. So these kind of advantages convince the customer to use an automated approach. So yeah, required functionality. Adam will take over here.
Thanks, Alp. Yeah, so Alp just ran through some of the the business requirements that we got from this particular customer. So now I want to go through the technical requirements that we got from the same customer. Of course, the two things are somewhat distinct, so we want to go through them separately. Yeah, so in terms of what we're trying to do, of course, we're trying to upgrade firewalls. There's a couple of pretty critical things that we need to be able to support with the automation. So number one is we want to be able to support high availability and all of its variations within Palo Alto Networks. It's probably true of all vendors, but certainly Palo Alto. Most of our customers run active passive. The vast majority of our customers run active passive HA. We do have a number of customers out there, though, that do run active. In my personal opinion, not recommended. Maybe not shared by Palo Alto Networks, but we do have a lot that do that. We also have users running HA clustering, something that we're increasingly seeing as well as more customers are moving to the cloud. We get a lot of customers out there running load balancer sandwich style deployments. which essentially means you have arbitrary groups of high availability VM series firewalls in between load balancers. And we need to be able to support all of those because effectively that's what our customers are using. Likewise, we also needed to support our full suite of hardware platforms. Anyone that's ever sort of tried to automate probably to be honest, any kind of platform, you know that there's a big difference between automating something that's really big and generally really highly powerful and something that's really, really small, not much computing power, maybe takes a lot longer to do anything on, right? So in our example, we've got everything from PA200 series, which are our tiny little boxes, all the way up to our chassis-based 7000 series. And we need to be able to automate the upgrades for all of them because honestly, the customers are using all of them. In addition to actually being able to upgrade, to perform kind of the basic automation of the upgrade, all of our customers want to make sure that the upgrade actually works, right? So to do so, we introduce the concept of tests into the actual automated upgrade flow. The very first type of test that we introduced is what we call readiness checks. The basic idea behind these tests is to make sure that whatever firewall or HA pair or batch of firewalls we're going to upgrade with automation, they're actually capable of being upgraded in the first place. So some of the tests that we look at are things like the high availability status to make sure if it's an active passive pair, it actually is active and passive and one's not non-functional. We look at things like to make sure they have valid licensing, they've got enough disk space for the upgrade, all those sorts of things. To use an actual real life example where why this is needed, we had a customer once, of course not using this automation, that scheduled an outage to upgrade their data center firewalls. We're all good here. I'm sure we all schedule outages with our business, right? They did it. They did the right thing in their example, and they scheduled it several months in advance, gave the business the notice, lined up all the stakeholders, and did all that other stuff that's important to do when you're doing data center upgrades usually. Then they came to do the upgrade a couple of months later, and of course, high availability was broken the entire time. In fact, the failover pair wasn't working. It was a network issue. They had to not only back out the entire change, but then had to wait another series of months to go off and do the upgrade again. Huge amount of wasted time, not to mention quite an embarrassment for that particular NOC engineering team. But these are all the sorts of things we do. We typically run them at the start of the upgrade, but I'll talk a little bit more about the upgrade flow a little bit later on. We also run another type of test that Alp's going to talk about.
So in terms of in addition to the readiness checks, we also needed to provide some comparisons for the before and upgrade. And for example, for HA pairs, comparing the peers, so we needed to develop and we needed to provide some solution for different components of the devices, like interface status or ARP tables. So these type of things should be like comparable before and after the upgrade, or between like HA pairs. And this should be I might want to configure the number of ARP tables that I can ignore, or some percentage, or I might want to ignore some routing flags if they're changed, they're okay or not. So we wanted to make sure all these are like in place, and yeah, we also need to provide some library that we can do API calls and store all this information in like JSON format, so we can later on use them to analyze. So the automation should also, of course, provide some backups, and these backups would back up the configuration and the software. So this would allow us to make rollbacks. So at any point in time, we can use this configuration and software to roll back to the previous release in an efficient way. In this customer case, the rollbacks was not automated. They wanted to like manage it manually, but we had to make sure that we have the test suites configured to make sure that firewalls are running in the desired state, even if they're rollback. So like handling the HA synchronization, or the routes are reconverged. So we need to like make sure this type of thing. So of course we need to also provide some kind of a report, like in a human friendly way and a lucid form. So you need to like have a list of all the checks, and with the comparisons of the differences of any. Yeah. Yeah, the automation solution Adam will take.
Thanks, Alp. Yeah, so that's effectively what we were building towards. That was the end goal that we're trying to build against. So now I'm going to talk a little bit about what we actually ended up building to kind of meet these needs, and ultimately how you can get access to it and use it and engage with it if you want to. So this is the flow. This is the entire flow that we built. The flow is fairly straightforward. Of course, each of these bubbles does a lot of heavy lifting, so please forgive this diagram for that. On the far left side, effectively the way the process starts is, of course, the user starts the upgrade. They do so in their preferred automation platform. Everything that we built is designed to be both modular and flexible. So a lot of customers that we engage with like to use just pure Python automation. So in other words, they really want us to just basically provide them or work with them to build a script to be able to do this automation. But we also have a large number of users out there running Ansible that we commonly deploy this automation solution to. I came to find at NAF last week that apparently Ansible has gone out of vogue. I still really like it, so and we still use it quite a lot. So I like Ansible for sure. There's also other ways you could run it, of course, but those are the two most common ones that we see. So after the users initiated the upgrade, and of course, regardless of which platform, you're going to choose which firewalls you want to upgrade during that process. So you might batch a whole bunch together, or you might choose to do a single HA pair or a couple of standalone firewalls. It's up to you. As soon as you do that, the readiness checks that we spoke about before run to make sure that the firewall or the batch of firewalls or the single firewall, whatever, is actually capable of being upgraded. So of course, it's up to you as the operator, as the engineer, to decide whether a failure of any readiness check, so for example, high availability failure like we mentioned before, or the licensing failure or a panorama connectivity state means you want to back out the entire change. But at that point, you have that knowledge. So you make sure that the firewall is ready to be upgraded. At the same time, we take what we call a pre-upgrade snapshot. As Alp mentioned before, we use what we call comparison tests or snapshot comparison tests to basically validate the state of the firewall before and after any upgrade, before and after any change, if you prefer. And in this particular example, because we're going through an upgrade process, we're taking the first snapshot before we start the upgrade process itself. The next thing, of course, is to start the upgrade process itself, which in doing so, of course, both manages the high availability failover process, upgrades the software, reboots, does all the other things that you would need to do manually, but of course it does it automatically. At the end of that, we go ahead and basically rerun the readiness checks in another form. We call them post-upgrade checks at that point, basically to make sure that there's no change there. But we also take the second snapshot, what we call a post-upgrade snapshot, and basically at this point, we can do a straight up comparison between the pre-upgrade snapshot and the post-upgrade snapshot and validate that nothing has changed or essentially broken. So an example, a real life example of why this is so critical. Many years ago, I was doing an upgrade for a customer of one of our larger firewalls. And I did it in the morning during a change window, as we always do. And I rebooted, the network came back, I did my usual kind of ping and connectivity tests. I hadn't automated the rest of the test suite, of course. In that environment, we had about 10 or 15,000 routes, I think it was. So anyway, all good, I waited, I did it early in the morning. 9:30 or 9 o'clock, everybody started rolling into work and people started yelling at me because, of course, there was something broken. Now, it turned out in that particular example, when I'd done the failover, the routing had failed to reconverge properly. So a whole bunch of routes, including DNS, the route to the main primary and secondary DNS server, don't ask, were both going out the wrong interfaces effectively. So DNS on campus was broken for a subset of users. So if you're wondering why it didn't show up in my, even my basic tests, it was essentially a subset of users, like a tenancy, if you can imagine. So got yelled at, got chewed out. With post-upgrade checks and our snapshot comparison tests, we would have been able to immediately see that a series of routes, although they were still in the routing table, had the wrong next hop interface, and we would have been able to know that something was wrong in the network. After all that happens, of course, we get a final report. Regardless of whatever happens with the checks, you get a report, but you also get a very clear pass or fail. So when we're dealing with automation, of course, we want to build processes that are very, essentially that you can branch off of. So if you've got a more complicated, or if you've got another external process that you want to use to trigger this automation, you can do that and know that you can, branch and do additional logic based on either the pass or the fail after the process is finished. When we decided to build it, we wanted to reuse as much code as possible effectively. So we based everything on our Python SDK, which is called Panos Python. So we based all of the tests, the automated logic, everything on Panos Python, and we made it to, we initially designed it most importantly to support our Ansible Galaxy collection. So everything's available in Python. You can write it however you like. You could integrate it into other tools if you would like as well. But Ansible is kind of our first-class citizen when it comes to consumers for the model. So again, we just based it on Panos Python, of course, because we wanted the ultimate amount of code reuse. In addition to using that for the actual upgrade process itself, we also wrote a new library or a new framework called the Upgrade Assurance Framework, which implements all of those tests that I mentioned before. So it's both our readiness checks, our snapshot comparison tests, and of course the underlying logic to actually take the snapshots, look at the tables of the device and save them to disk, and then finally do the comparisons and run the tests. This again, maximum amount of Python reuse, so it actually uses the Panos Python SDK under the hood. It's open source. Everything I've listed here is open source. That's effectively how we make it work. It's all available, of course, in Ansible as well as Ansible modules. So our tests, snapshots, everything are available in our Ansible Galaxy collection. Again, open source that you can use today. Otherwise, you can install everything from PyPy as well. Finally, I've just talked about all the stuff that we just released. We just open sourced. But finally, when we actually go to deliver these projects for customers as a services organization, generally speaking, what we do is we combine them all into tailored Ansible playbooks for the customer. Again, Ansible is the example, but we sometimes do it with Python as well, depending on what the customer wants. Essentially, it just combines all those all those open source solutions that I just mentioned. And because they're all open source, it's a very low friction deployment for most customers, very easy and simple support model. You can basically raise a GitHub issue. Or of course, you can come to us from a professional services standpoint to get help if you ever need to. That also includes, of course, all the checks as well as the report generation. All of it, of course, is customizable. Just one quick thing in here, because we primarily target Ansible, we get a lot of customers ask us whether or not we can run either the checks or the entire process outside of like the upgrade process itself. Perfectly supported. So I had a customer just the other day ask me if they could run the snapshot test like on an hourly basis, just to make sure the network's not kind of drifting from what they expect it to. And there's no reason you can't. You absolutely can do that. It's very trivial amount of Python to do so if you want to, and cron or your preferred scheduler. So this is an example, but Alp, I believe we're going to run the actual demo now, aren't we? Okay, sure. So this is in this case, this is an example of the actual playbook running. Everybody here's probably seen an Ansible playbook. It's not particularly exciting. In this case, it's running against a single firewall, showing that we're doing both the tests and taking the backups and all the other stuff. It's basically what it looks like if you're executing it within Ansible. There you go. From here, we're going to also show the sample upgrade report. Do we have the report here to show? Yep. So we do have a sample upgrade report just to show you kind of a better idea of what the actual data looks like, so you can do a comparison for yourself. Yeah, thanks, Alp. So you can see in this example report, we've got a couple of failed tests up the top. So we've got NIC status and route status are both listed as not okay. In this case, you can very clearly see the reason NIC status is not available, has gone bad, is because the interfaces that were up before the upgrade are now gone down. And of course, we have routes that are actually fully missing. Like I mentioned before, routing and all of our snapshot comparison tests are not just based on whether something is like in the table before, but now it's gone. They're based on anything that's changed in the table at all. So if you really wanted to, you could do like an ARP table test that checks to see whether like the time to live has gone down, which of course it will. The age has gone up, which of course it will have. But you can basically check any aspect of the data in any of the tables that we support. So this is an example. In this case, it was just simply gone altogether. So now back to Alp to talk about the actual case study results.
Thank you, Adam. So let's see how it's all ended up. So what we achieved is that we delivered a customer tailored solution. So we were like able to upgrade more than 500 firewalls in a couple of months, and which actually we did 100 firewalls during a single maintenance window during a night. So that was a great achievement, and this has made to a reusable solution then that we can adapt to different customers and environments. With like we had like lots of switches and options in this playbook that we can adapt to different needs.
So let's have a look at the firewalls we have. We have two firewalls configured in HA, connected to Panorama. They're currently running on 10.1.12, as you can see here. They're an HA pair. They're both connected, as you can see, and all the configuration synced. And they have the configuration sync configured on them between active and passive peers. And I want to update them to 10.2.3 with the automation tool we have. So yeah, to 10.2.7H3 exactly. I want to. So I started the automation. It will take some time to upgrade both firewalls. So the upgrade automation went fine. So let's have a look at the outputs. So as you can see here, we have like different tasks within different colors like this, which requires the user's attention. And in the very end of the playbook, we generate an HTML report to the user, which looks like this. And at the very top, you're seeing an HA pair comparison, the firewalls we recently upgraded. And this is showing the existing expected differences between the peers. So the user is aware of these differences. They were existing before the upgrade. They're not an issue, but just to present it to the user. And if we go down, we also present towards the bottom. We present the per firewall results reports like this. For example, the content database version changed during the upgrade, which is expected as we upgraded during the upgrade, and routing flags have changed as well. So let's go back to Panorama to see the current status of these firewalls. Let me log in here. So we will check the firewall status in the Panorama managed devices. So if we should see the firewalls here. At the very top, you'll see the HA pair firewalls here, and they're both upgraded to 10.2.7H3, and they're both connected. So which is good. Before the upgrade, the firewalls were in version 10.1.12, and this concludes that the firewalls upgraded successfully.
Of course, I mean, we can't say enough for sure. We are like constantly trying to improve it. We're like trying to add new tasks, for example. We have discussed that we can deploy some server that we can test the traffic if it is actually flowing through the firewall. Like we can deploy some separate server, and this could generate some traffic, and then we can check the logs on the firewall that is this traffic is actually passing by the firewall. But like in the current status, we're like taking snapshots of the states, the configurations, and the runtime status. So like yeah, it is something, but of course this could be improved in that kind of ways as well. It was working fine, more or less. But for example, we were not involved very much. Like we did a knowledge transfer to the customer, and like we were involved in a couple of firewalls, and they had like maybe a couple of network engineers as well. So it was like executing in a very nice way that we didn't need to involve very much. It was like a couple of issues maybe that were arise during this maintenance windows, and maybe we did some fixes for them. But like I said, we didn't need to involve very much during this process because it was like good enough to handle that upgrades.
In this example, I believe they were all hardware firewalls. I don't. Did they have any VM series?
Yeah, it was all hardware firewalls. Yeah, but for example, in the lab that I'm currently running, it's on the cloud, so it's running on both hardware and software firewalls.
Not really. I guess that's where the tests come in to kind of prevent like that happening if there's something in the network that we didn't expect, I guess. But generally speaking, the actual upgrade process itself doesn't change dramatically regardless of hardware platform from a Palo Alto Networks standpoint. So the upgrade's always basically the same. The actual process itself is always the same. It's just making sure that the actual outcome of the upgrade doesn't break the network. So no, to answer your question, something that's configured on the device itself wouldn't do it. But the upgrade itself may cause issues, which is what we test for. So it's a good question. Most of the component, or pardon me, let me rephrase, all of the underlying components that we use to build the playbooks are open source and freely available. The actual playbooks themselves, our experience so far has been that ultimately they're not reusable. The customers want bespoke versions of them because they want to tweak certain things. In some cases, we have customers that want us to like pause at certain points. I'm not entirely sure why. Some customers want to do really specific things with like the inventory or how many batches they do at once. So far, we haven't come up with a reusable playbook for just everybody, but we are kind of working on it as well. And when we do, we'll certainly open source it. Most likely what we'll end up coming up with at some stage is something that's kind of really basic that maybe is good for like a lab environment. And then from there, the customer can, tweak it as needed to build out. So that was before the automations. So that was if, maybe I didn't explain it well enough, but in that scenario, if I was using the tests exactly as they are written, it would have picked it up, like guaranteed. What's a test? Sorry, can you explain what a test is? Nah, I'm just kidding. I'm just kidding. Yeah, it's good. Look. Yeah, I won't elaborate like too long on it, but basically, I think we all agree, whether you're a network automation specific person or you're a software developer, everything needs to be covered by tests. The challenge, of course, in the network automation space is very hard. Generally speaking, it's very hard to reliably mock really complex devices like firewalls, routers, switches, maybe switch not so complex. So really, from a QA perspective, what we generally see our customers do, certainly for this kind of automation, is we obviously test the actual underlying modules and the code as reliably as we can. We do spend the time to build the mocks and do that work. Then the customers generally roll it out in an iterative process, starting from like a small environment and getting bigger and bigger and bigger and bigger. So for example, this particular customer, when they upgraded those, all those firewalls at once, they didn't do that in the first outage window, right? They just smaller batch, made sure they worked, tests all passed, and then they, continually built it up. So in that way, it's kind of a low-level version of QA, but of course we test the code as well. Hopefully that answers it.
Nothing in particular now, but like since this is a playbook that you can run in parallel, and they were able to execute this from multiple machines actually, and they were interacting with the firewalls directly, so there was no like bottleneck in terms of the network. So actually what they did is they were running multiple engineers, and one playbook was running in 10 firewalls maybe, and like it was possible to like execute in like 100 firewalls in that case, but we didn't like work on something like that yet. Yeah,
I think in this case the bottleneck is always going to be the actual firewalls themselves. So for sure, in other sorts of environments you might have to do some of that stuff, but in this case we didn't see any other bottleneck. It was just a firewall API basically. Yeah,
depending on the model or like, yeah, maybe, yeah.
Yeah, it certainly would be possible. Yeah, it does stay relatively consistent between versions and hardware platforms. So yeah, that's a good idea. You could do that for sure.
Yeah, it includes the configuration, but not just the configuration. It includes the runtime status, like the interface status, the routings. So it's not just the XML, but the actual runtime components as well. Yeah. For the rollback, we have the configuration snapshot as well. So configuration XML is there, so we can use that for the rollback. Yeah, in case of HA firewalls, for example, we first start with the passive firewall. So because we want to make sure that it is working, like we first fail over to the passive firewall, but we start with the active firewall upgrading. So we want to make sure the passive firewall is processing the traffic. So before failover, for example, we take snapshots and then we failover and we take another snapshot and we compare this interface status and routings between these two peers. So we make sure that during the failover, it didn't cause any changes and it's still able to process the traffic even before we start any upgrade. And then we initiate the upgrade on the active firewall. And like on each failovers, we do these comparisons to make sure it's like functional. But it's like, I wouldn't say they're for standalone firewalls, but this is what we do for the HA, yeah. We have like, but still Ansible, but we also adapted this to AWX, the Ansible server. So it provides some UI to the customer, so more understandable. So it gives you more details on failures. For example, if you have some failure and of course, if you run just Ansible on the CLI, sometimes the details are not available if you don't enable debugging. But with the AWX, you have like more details. But apart from that,
to be honest, like essentially because everything's written in Python under the hood, at some stage there might be a new automation framework that comes out that becomes, the go-to. Currently, we're not targeting anything in that space. Some customers certainly makes it a lot easier just to do it purely within Python. We actually have another open source Python package that's currently being worked on that uses the code under the hood to do upgrades. But no, to answer your question, we're not currently targeting any specific other automation platform.
Yeah, actually, we have this Python upgrade, this Python tool.
Yeah,
Baumeister upgrade, right?
Yeah, that's the one.
Yeah, so we have also in Python, which is executing similar steps, all in Python and using the underlying library that we developed here. So this library is like for ensuring the tests and snapshots. So in this customer case, we were using Ansible, but there was another project that we worked on, and that was purely in Python, yeah.